What's up, math scholars? This is 9-3, day 2. Actually the last day of notes of the whole week, because tomorrow and Thursday a review and Friday's a quiz. So that would also mean tonight's the last homework of the whole entire week. So who's excited about that? Yeah. By far the most enthusiastic intro we've had this week. All right, so let's talk unit circle real quick. There's some things called quadrantal angles. This is a new vocabulary word. Quadrantal angle. A quadrantal angle would live at a hot spot. I call these guys my hot spots because they're easy to find. Their coordinates are easy to use. But it would basically be 0, 90, 180, 270, 360, and I could continue spinning. What comes next after 360?
450.
450. What comes next after 450?
540.
540, and I could go all day long. All those guys would be quadrantal angles. Okay? So if you ever see that word now, you know. All right, go ahead and write down what you're seeing in this red box. Let me explain. So yesterday we introduced to you that sine means y, cosine means x, and tangent means y over x. So you might be curious, why are we throwing in over r, over r? Yesterday you didn't need the over r because we were working with unit circles, and the radius was always a 1. So it's okay skipping that. Today we'll be working with some circles and some triangles that have a bigger radius than 1, like a radius of 5, for example, and then you'll need to have that over r for sine and cosine. Do you know why you don't need to deal with r at all in tangent? Because tangent is like opposite over hypotenuse, or opposite over adjacent, my bad, and you don't use the hypotenuse, the radius, at all. The radius is the hypotenuse, okay? Yes. Yeah, I will hit the lights. All right, so here's what we got going on this one. We are going to be looking at the unit circle. We're going to be looking at 270, so we won't need to worry about the radius because the radius is just a 1. Well, actually, I will put over 1. That will help us in our cosecant, secant, and cotangent. It will help us with doing reciprocals. So let's try sine first. Go to 270 on your unit circle. Looks like some of you have put the unit circle away. Grab it back out.
You said that we don't need it.
I said we were done filling it out. I didn't say we wouldn't need it. So find 270. What is the y value at 270? -1. Now what's the radius? 1. So I'll put it over 1 just so I can have it written out as one guy on top, 1 on bottom. But the answer is -1. The reason I put it like this is let's travel down and do cosecant right now. If you remember from last week, cosecant is the reciprocal of sine. So you'll just flip it upside down, and it will also yield an answer of -1. Now, can I have the fraction chat with you guys? A little heart-to-heart fraction chat. Is this having a negative out front and having a negative down below and having a negative out front of everybody exactly the same thing?
Yeah.
Yes. So I'm glad we had that chat. My last class felt like this and this were different. So it's the same thing regardless of where the negative is. If there's only one negative, it can go on top, bottom, or out front. All right, let's try. I'll do a new color. Cosine. So go to 270. What's the cosine value? I'll go ahead and put it over 1 just for reciprocal purposes because the radius is 1. But what is 0 divided by 1? 0, of course. Let's go ahead and travel down to secant and reciprocal our answer. So 0 over 1 would actually reciprocal to 1 over 0. Are you allowed to divide by 0?
No way.
That answer would be undefined. Yesterday we chatted that tangent can be undefined. Now I guess we've learned that secant can be undefined. And now let's do tangent. Tangent, just a refresher, is y over x. So what's the y value at 270? What's the x value? Are you allowed to do that?
No way.
So that's undefined. What about the reciprocal, though? Would the reciprocal also be undefined?
No.
Oh, we would flip it. It'd be 0 over -1. So it's just 0. So we have 2 of the 6 are undefined. I think that's going to be true at almost every hotspot because you just have the zeros involved at those quadrantal angles. Okay. All right, let's go ahead and locate 180 on the unit circle. Point to it. What's the sine value? Now, I kind of talked to Spencer when we were pausing our recording. Sine is technically y over r. And yesterday we didn't do the over r because r was always a 1. But today, if you want to do that, you can to aid yourself in the reciprocal step. So 0 over 1 does equal 0. Sine is 0, I agree. But what's cosecant? 1 over 0, which is?
Undefined.
Does that make sense?
What's the R represent though?
Radius. And in a unit circle, the radius is 1 unit.
Indeed.
All right, let's try cosine. I'll do a new color. Cosine at 180. What's the x value? -1. I could put an over 1 just to be nice, but what's the reciprocal of that -1? Also -1, right? The reciprocal of -1 is also -1. What's the reciprocal of 1? Positive 1. Positive 1. Yeah, that's easy. All right, and tangent. Tangent at 180. We're going to do our y value on top, our x value on bottom. So y is 0, x is -1. That would equal 0. And let's reciprocal it for cotangent. It'd be -1 over 0, and that's undefined. So it's undefined any time you're trying to divide 0. All right, this is our first one of the day where our radius is not going to be a 1. This is not on the unit circle, okay? Let's look at it closely. -4, 3 is this coordinate, which means it's outside of the unit circle. The values are larger than the unit circle, okay? So we are going to actually solve for the radius, which as far as this triangle is concerned, it's the hypotenuse. Do you want me to draw it bigger so you can see it? That's what I did last period. I drew it bigger. I blew it up. I don't think I can blow up this circle without blowing up everything. But anyways, so here's my radius. This measurement here is technically a 3 because that's how high up we went to get to that coordinate of 4, 3. I mean, here's my coordinate 4, 3. -4, 3, sorry. So how long would this technically measure? 4 units, right? Even though it's a -4, it would measure 4 units. Think geometry. You can't measure -4 inches, right? So let's solve for r. How would we solve for r? 3 squared plus 4 squared equals r squared. My geometry scholar should know how big r is. What? R is 5. Good. It's a 3, 4, 5 circle. So r is 5. So basically my x value is going to be a -4. My y value is going to be a 3, and my r value is going to be a 5. So we're ready to do our trig ratios, I believe. Any questions so far?
How did you calculate that 3 was that side and 4 was that side?
Oh, because to get to this coordinate, I would have to go left the x amount.
Oh,
So
yeah.
left
Okay,
4, and up the y amount 3. Make sense? Okay. So sine would be y over r. We wrote that down earlier. So 3 over 5. Make sense? How about you guys tell me what cosecant would be? Friday? Let's try cosine. Cosine would be x over r. So -4 over 5. So you guys tell me what secant would be. I'm just going to put that negative out front. I need a third color. How about green? Tangent is y over x. So 3 over 5? No. Oops. Oh, my bad. Let's put my radius in there. I'm going to put my x there. Thank you. And then we do our reciprocal for cotangent. I'll put my negative out front. -4/3. Right? Okay, so this is our last topic. It's called a reference angle. You would write down what I got in my green box. A reference angle is denoted theta prime. Theta prime. And it's the angle that theta makes with the x-axis. Now there are 3 scenarios down here that you can look at. I'm not going to make you copy all 3 scenarios because that would take forever. But depending on what quadrant you're in, that's how you would calculate out your theta prime. When you're done rating, I'll show you these 3 scenarios. Yeah.
Theta?
Theta. Theta. All right, so if you are in quadrant 1, which they didn't include because quadrant 1's easy, if this is your theta, and the theta prime is the angle that your I can't think of the name, terminal side makes with the x-axis, theta and theta prime are the same. So quadrant 1 is easy. Quadrant 2 gets a little harder. Let's pretend my theta, I'm playing pretend here. Let's pretend my theta is 200. Oh, sorry, that wouldn't even make sense. Let's pretend it's 100. It's the paint fumes. All right. You can't, luckily if you're at home watching this video, you can't smell the fumes we're smelling. But anyways, if your theta here is 100, you would be living up hereabouts, right? Your theta prime is this angle in green. So what I do is I take the 180 and subtract off 100. So what would theta prime be? 80. Does that make sense?
Yes.
Let's try a quadrant 3 scenario. So we're playing pretend. Let's pretend this is 200. Your theta is 200. Now theta prime is the angle that your terminal ray is making with your x-axis. So since this is 180 here, my theta would be 20. Theta prime would be 20. Make sense? Let's try one down here. Let's pretend this is 315. Plain pretend. This is 360, correct? So how big would this theta prime be? 45. Okay, so we're going to try a couple of these reference angle problems, okay? Let's try 5 pi over 3. So my advice for the radians ones is just convert it to degrees real quick. So just look on your unit circle to convert 5 pi over 3. Where does 5 pi over 3 live? Down at 300, right? So let's go look at where 300 lives. What?
I hear like a really loud noise.
So 300 degrees is located approximately here. Everyone agrees?
Yeah.
We want to find theta prime, which is our angle that that terminal side makes with the x-axis. So if this is 360, how big is theta prime? Make sense? Now, since they started you in radians, you probably want to give your answer in radians. So the easiest way to do that is look at the unit circle at 60 and just look at its radian equivalent. Yep. Okay. What about negative 130? Do you know where negative 130 is? Not particularly. So go ahead and add a 360 to it. It's located at 230. Y'all agree? So 230 probably somewhere down here. Because I know this is 180 and I know this is 270. You know where your theta prime would live? Between your terminal ray and the x-axis. So in here. So do 230 minus 180. 50. Make sense? So you understand reference angles? Mm-hmm. All right, then I go ahead. I think we can be done. We can skip the last two. All right, so I did go ahead and shorten it down from what it appears here. I made it 8 to 32. So cut 2 problems off. Make your job tonight a little easier. Thanks for watching the video at home, and hopefully you're having a happy Tuesday.